Assalamu alaikum, dear students. I'm your tutor, Dr. Amir Rashid, with the class of today based on the concept of parallel plate capacitor. Let's remind you that yesterday's class we did about the capacitance. We did about the capacitor. Capacitance क्या होता है? Capacitor क्या होता है? Capacitance is actually the measure of the ability of a conductor to store the charge. And usually जब हम ये capacitor ले लेते तो यूजुअली जब हम कैपेसिटेंस का कॉन्सेप्ट ले लेते हैं we assume that the two parallel plates held apart from with some distance d having charge plus and negative. So these two plates are the conductors which are separated by some distance d and in between इनके बीच में ये जो है ये मीडियम है, ये इंसुलेटिंग मीडियम है. इस इंसुलेटिंग मीडियम में जब चार्ज स्टोर होता है तो इस सारे अरेंजमेंट को, इस सारे वाले अरेंजमेंट को फिर कैपेसिटर का नाम दे दिया जाता है. ठीक है बेटा, दैट इज द कैपेसिटर. दैट इज द कैपेसिटर कैन बी डिफाइंड as an arrangement of two parallel plates, conducting plates separated from each other by some distance d with some insulating medium between them containing some charge. So that's called the parallel plate capacitor. ठीक है बेटा, तो दिस parallel plate capacitor की कुछ कैपेसिटेंस तो होगी ही. ठीक है बेटा, जैसे कि हमने सिंपल डेफिनेशन पढ़ा था, अगर Q is equal to CV, that means C is equal to Q upon V. ये हमने definition of capacitance पढ़ा था. That the capacitance can be defined as the ratio of the charge to the potential. ठीक है बेटा. Now today we will be deriving the relation. Today we will be deriving the expression for the parallel plate capacitance. That is हम parallel plate capacitor की capacitance निकालते हैं. ठीक है बेटा. तो फॉर दैट पर्पज पहले हमें, इससे पहले कि मैं इस पैरेलल प्लेट कैपेसिटर की कैपेसिटेंस निकाल दूंगा, मुझे पहले पैरेलल प्लेट कैपेसिटर बनाना होगा. ठीक है बेटा, यहां पे मैं पैरेलल प्लेट कैपेसिटर बनाता हूं. आई विल टेक टू प्लेट्स. ओके बेटा, देख लो बेटा, इट कंसिस्ट्स ऑफ तो ये पैरेलल प्लेट कैपेसिटर, पहले हम पैरेलल प्लेट कैपेसिटर की थोड़ी डेफिनेशन लिखते हैं. ठीक है बेटा, इट कंसिस्ट्स ऑफ टू लार्ज प्लेन पैरेलल, इट कंसिस्ट्स ऑफ टू लार्ज parallel conducting plates. Conducting plates separated by a small distance. ठीक है बेटा, सो द पैरेलल प्लेट कैपेसिटर कैसे बनता है कि जब हम दो प्लेट्स लाते हैं, पैरेलल प्लेट्स लाते हैं. ठीक है बेटा, ये एक प्लेट लेते हैं और ये एक दूसरा प्लेट लेते हैं. फॉर एग्जांपल इसकी चार्ज सिग्मा है, इसकी चार्ज सिग्मा है, तो बस फर्क सिर्फ इतना है, इस पे चार्ज पॉजिटिव है, पॉजिटिव है, पॉजिटिव है, पॉजिटिव है, लेकिन इसमें चार्ज क्या है बेटा, इसमें चार्ज नेगेटिव है, नेगेटिव है, नेगेटिव है. ठीक है बेटा, तो दैट मींस टू पैरेलल प्लेट्स सेपरेटेड बाय स्मॉल डिस्टेंस. ये स्मॉल डिस्टेंस है. ठीक है बेटा, तो दैट कॉम्बिनेशन विल कंप्राइज व्हाट इज कॉल्ड एज पैरेलल प्लेट कैपेसिटर. अब इस पैरेलल प्लेट कैपेसिटर कुछ कैपेसिटेंस होगी. अब उस कैपेसिटेंस को हम यहाँ पे डेरिव करते हैं. बस फर्क सिर्फ इतना है, इसका चार्ज पॉजिटिव चार्ज डेंसिटी है, इसका नेगेटिव चार्ज डेंसिटी है. ठीक है बेटा, और इन बिटवीन देयर इज सम डिस्टेंस बिटवीन देम. यहाँ पे इंसुलेटिंग मीडियम है. ठीक है बेटा, सो वी विल डिराइव द कैपेसिटेंस ऑफ दिस पैरेलल प्लेट कैपेसिटर. सो व्हाट इज actually a parallel plate capacitor? A parallel plate capacitor consists of two large parallel conducting plates. ये दो conducting plates है. ठीक है बेटा, इनमें opposite charge है. ठीक है बेटा, separated by small distance. इनके बीच में जो है distance, ये small distance है, ज्यादा नहीं है, कम है. ठीक है बेटा, separated by small distance d. ठीक है बेटा, तो यहाँ पे हम ये करेंगे, suppose A is the area of each plate. ठीक है बेटा, suppose A is the area of each plate. Suppose A is the area of each plate. चलो हम यहाँ पे ये मानते हैं कि ये एक प्लेट, ये जो एक प्लेट है और ये दूसरा प्लेट है, इस प्लेट का एरिया कितना है, ए. सपोज ए इसका एरिया. ठीक है बेटा, ए इज द एरिया ऑफ ईच प्लेट एंड डी इज द डिस्टेंस बिटवीन देम. ठीक है बेटा, डी इज द डिस्टेंस बिटवीन देम. D is the distance. D is the distance between them. ठीक है बेटा, D is the distance between them. Between two plates. Between them means between two plates. ठीक है बेटा. और plus minus sigma is the charge densities of the plates. Is the charge densities of the plates. ठीक है बेटा. Is the charge densities of the plates. Charge densities of the plates. चलो इसकी प्लस सिग्मा है, इसकी नेगेटिव, दैट इज पर मतलब चार्ज डेंसिटी इसकी पॉजिटिव सिग्मा है, इसकी नेगेटिव है. ठीक है बेटा. डेंसिटी ऑफ द प्लेट्स. ठीक है बेटा. so 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 what we have supposed here that let A be the area of each plate and D be the distance between the two plates, and let the charge density of the plate is positive sigma and the charge density of down plate is the minus sigma. ठीक है बेटा. so it's the charge densities, right? The charge density of the plates, right? that is plus minus q, that the charge on the each plate. If you remember the class when we are doing the continuous charge distribution, we derived the relation that charge per unit area is called, we did a concept over there that the charge per unit area is called linear charge. Charge per unit area is called surface charge density. What we did there was like that charge per unit area is called surface charge density, right? We did it. So it means charge is equal to sigma into area. ठीक है बेटा. So okay, it means positive and negative charge will be given as plus minus sigma into A. Okay, so accordingly we can write here the positive charge on upper plate and the negative charge on the down plate will be given as plus minus sigma into A. Got it? So it's like that. This sigma is the charge density. ये जो हमने लिखा sigma is the charge density. So if you can remember when we were doing the electric field between the plates, if this was sigma plus sigma minus sigma, this are region 1, region 2, region 3. What we found there was that the electric field in this region and this region was 0, but the electric field in between the region was sigma upon epsilon naught. If you remember the class when we are doing the electric field between the plates, right? In the region R1, R2 and R3. The electric field between the plates was sigma upon epsilon naught, but the electric field outside the plates was 0. Got it? So similarly, we have two plates over here. The electric field in between will be sigma upon epsilon naught, but electric field outside the plates will be 0. So I'm writing that here, right? So it means electric field outside is equal to 0. Electric field outside is equal to 0, but electric field in between is sigma upon epsilon naught. Okay, electric field in between, because we have done that part when we were discussing the electric fields between the plates and outside the plates. For example, if it was sigma 1, it was sigma 2, and then it was electric field in region 1, region 2 and region 3. And over there, if the charge density was plus sigma and this was minus sigma, then the electric field in between the plates was given as sigma upon epsilon naught, and in this region it was 0, right? I hope you remember that class. So accordingly, I have written here the electric field between the plates is sigma upon epsilon naught. Got it? So when the electric field between the plates is sigma upon epsilon naught, so I will write it here. Yes. Okay. See, in above the plate, in the region above the plate, in the region is above and below the plate, above and below the plate, above and below the plate, electric field is 0. Electric field is 0, right? That means above the plate and below the plate, electric field is 0. Why? If the surface charge density of above plate is sigma 1, so in this region there will be two electric fields. One is because of this plate, another one is because of this plate, right? So it means electric field in this region will be, see, one will be sigma upon, because of this plate, that will be minus times sigma upon 2 epsilon naught. if we are taking the direction from above to below positive, right? If we are taking the direction from above to below as positive, then because of this plate, the electric field over here will be uh, sigma upon minus times sigma upon 2 epsilon naught. Okay, why negative? Because the positive charge, because for the positive charge the electric field is outwards radially, but we are taking this is one plate having the positive charge density, it means electric field will be radially outwards, but we are taking the electric field from above to below. That means because of this plate electric field in this will be this, and plus because of electric this plus times because of this it will be sigma upon 2 epsilon naught, which is equal to 0. This plate, the contribution from this plate, because the electric field is plate की वजह से, because the electric field because of this plate in this region will be plus times sigma upon 2 epsilon. Why? Because its electric field negative charge, when we negative charge, its electric field is vertically down inwards. Sorry, it's radially inwards. So it means its electric field is radially inwards. Its electric field is radially inwards, right? Like that. So it means, and already we are taking the distance from above to below. That's why the electric field because of this plate in this region will be sigma upon 2 epsilon naught. So therefore total electric field in the plate above the plate from by this plate and this plate will be 0. Got it? So this is how the electric field in this region is 0. And similarly electric field below the second plate, down the second plate, I mean under the second plate will be 0. Okay, so it means below the plate, in the regions above and below the plate electric field is 0. Got it? So electric field here is 0, but between the plates, between the plates electric field is 0. Sorry, electric E is equal to sigma upon epsilon naught. Okay, sigma upon epsilon naught. How between the, now see how, now you will ask the question, how between the plates electric field sigma upon epsilon naught. First it is electric field is sigma upon 2 epsilon naught. First we will see in this, in the region in between the plates, let us see how the electric field is equal to sigma upon epsilon naught between the plates. Okay, so first because of this plate, what will be the electric field? That will be E is equal to sigma upon 2 epsilon naught, right? And because of this will be plus sigma upon 2 epsilon naught, plus sigma upon 2 epsilon naught, that is equal to 2 times sigma upon 2 epsilon naught, it is equal to sigma upon epsilon naught. So that's how the electric field between the plate is sigma upon epsilon naught. Okay, now come here. Sigma upon epsilon naught. So the direction of this field that is between the plates is from positive to negative. Huh? The direction of this plate, the direction of this field is from positive to negative plate. Okay, is from positive to negative plate. That's like that, from positive to negative plate. Negative plate. Now, what will be the potential difference between the plates? If you remember, electric field was given as dV by dx, right? That implying that potential difference is equal to E into D, right? That is the potential difference between the two plates can be written as electric field in the distance. Got it? How we have written it? Because we know that there is a relationship between the potential and the electric field, right? So V is equal to E D. Electric field in distance between the plates. So we can write the potential here. Potential is equal to V equal to E D. Okay. Potential is equal to E into D. Potential is equal to E into D. So it means V is equal to, what is electric field? Electric field is sigma upon epsilon, so sigma D upon epsilon naught. So this is the potential between the two plates, right? Potential between the two plates is sigma D upon epsilon naught. So that, as we know that As we know that Q is equal to CV, implying C is equal to Q by V. That means C is equal to Q upon V. That is equal to Q upon V is sigma D upon epsilon naught. That is equal to Q epsilon naught upon sigma D. Okay, beta. That means capacitance C is equal to. Now we will write here. Okay. That is C is equal to Q into epsilon naught into, for sigma we know that this sigma we know that charge per unit area is equal to sigma. It implies sigma is charge per unit area. It means for sigma I will write charge per unit area into D, that is equal to epsilon A upon D. So implying that, so this is the capacitance, okay beta. So that is the epsilon A upon D. So that is the capacitance of a parallel plate capacitor. So this is the parallel plate capacitor capacitance. Capacitance of parallel plate capacitor is epsilon A upon D. So that is a parallel plate capacitor whose capacitance is given epsilon A upon D. So again I will review the whole chapter. I will review whole concept of parallel plate capacitor. The parallel plate capacitor is actually a combination of two parallel conducting plates separated by some small distance d, right? And those plates have opposite charge densities, equal but opposite charge densities, and in between the two plates is some insulating medium. Okay, then after that we have to find the capacitance of the parallel plate capacitor. So we know that we as in the previous class when we are doing the linear charge distribution, we were doing the surface charge distribution, we were doing the continuous charge distribution, and the electric field because of continuous charge distributions, like when we did the electric field between the plates, in between the plates the electric field was given by sigma upon epsilon naught. As you remember the class when we are doing the electric fields because of linear charge distribution, continuous charge distribution, surface charge density, and volume charge density. And in between the plates, we found there that the electric field was given as sigma upon epsilon naught, right? So when between the plates sigma upon epsilon, electric field is between the sigma upon epsilon, while sigma is the surface charge density of above plate and below plate, and outside the plates the electric field is zero. And the direction of this field is from positive to negative, right? And we know it that the electric field, whenever there is a positive charge and negative charge, electric field always comes from positive charge and terminates at negative charge. The same thing is over here, right? Then we know that potential is given as ED, right? Potential is given as ED. So it means potential difference between the plates is given electric field with the distance between them. Electric field is sigma upon epsilon naught into D. As capacitance is given by charge divided by potential, that means charge divided by potential is sigma D upon epsilon naught, sigma D epsilon naught. That means it is Q epsilon sigma D. So that is, but we know that this here that surface charge density is given by charge per unit area. So instead of surface charge density sigma, I have written here charge per unit area. Charge cancel, it is epsilon A upon D. So that is the final relationship, that is the final relation for the capacitance of a parallel plate capacitor. So if you will see from here, that is the capacitance as we have found here, see. So finally the capacitance of parallel plate capacitor is given as epsilon A upon D. So from here we can conclude that the capacitance of a parallel plate capacitor depends upon the area of the plates and distance between the two. That means if the area of the plates is more, it means capacitance will be more, and if the distance between the two plates will be less, capacitance will be more. So it means if we have to develop a capacitor of large capacitance, what we have to do, we have to increase the area of the plates, but we have to decrease the distance between the plates. That is how we can increase the capacitance, because the capacitor we usually in integrated circuits, in telecommunications, in mobile phones, right, in circuits we use and in the generation of electromagnetic waves we use capacitors. So if we need the capacitance of higher magnitudes, what we have to do, we have to increase the area of the parallel plates and we have to decrease the distance between the two. So from that we can find here, so from that we can write that the capacitance is capacitance is directly proportional to the area, capacitance is inversely proportional to the distance, right? And capacitance is directly proportional to the permittivity. So these things, so it means increasing the area, capacitance can be increased, decreasing the distance between the two plates, capacitance can be increased, and it also depends on the permittivity of the medium. What is this a permittivity? This is the permittivity of the medium which is between the plates. So I hope that's all for today. So the final relation which we got for the capacitance of a parallel plate capacitor is epsilon A upon D, while A is the area of the plate and D is the distance between the plates. So I hope that was all for today. Let's meet in the next class. Till then, Allah Hafiz.